Hello senior design teams, I hope everything is going all right. In this lecture, I will kind of remind you and refresh your memory on conceptual design and the steps involved in it. This is again something that we've covered in details in 361. Here I'm just briefly mentioning and refreshing your memory. This is one of the most important steps in your design process, and this is a step that a lot of teams don't follow and overlook, and they will run into troubles later in their project. So let's see. So this is a flowchart that we've talked about. All I want to mention is that now we are focusing on this step of the process, which is the conceptual design. If you remember, concept, there's a difference between an idea and a concept. The concept is usually a sketch or rough 3D model, so it shows to the degree which your product will satisfy the customer needs. So it's an approximate description of the technology, working principles, and form of product. It could be anything, ranging from a sketch to a clay model to an approximately working prototype. Could be considered a concept. Here I have some more examples for you. I didn't know what to call this. I called it a surfboard. It's a concept for a type of water vehicle, let's call it. One thing I want you to see is the different sketches and different ideas that the design team had for this product or for this concept. All you see here are a form of a concept. Some look better, some look more basic and just hand sketches, which is fine. Here's another famous product from Volvo. And you can see that it started with very, very rough sketches of the idea and of the concept, and then kind of developed that sketch into 3D modeling and 3D rendering. And then if you look further, it kind of evolved from there and had more realistic rendering of the idea. So if you have time, please search Volvo Ladan, and you're going to see the process of designing and creating the concept. Again, my point was it started from very, very rough sketches. Here's another nice idea. A light that turns on or off by placing a ball, and the ball rolls down, and you can pick it up again and put it in the top slot, and it will turn it on or off. So my point for showing this concept is such a simple thing as a desk lamp or desk light. You can see how many different ideas and how many different concepts the team developed and put together. So these were not done on one sheet. These are different concepts. They just put it next to each other for purpose of presentation. But you can see nothing is too simple to show to think about every aspect of it and come up with different ideas. Here's another one that you can see. It started with a super rough sketch, and they developed a cardboard model of it. So this is not a prototype. This is a concept. Again, a different form of the concept. And again, here even this is a concept that developed for a soy sauce cruet. Here's another example for you. Something as simple as a mask. Again, I want you to focus on how teams thought about everything and developed, I don't know, tens or maybe hundreds of different ideas and put together a concept for an actual product. Okay, so the examples that I have for you in 361, the generating of a concept was a Senko power nailer, a handheld nailer that a team developed and worked. So if you remember, developing a concept is a 5-step process. And again, this is a very, very important to follow these steps if you want to have a successful product, successful senior design, and prototype and product. Okay, so step 1, we're going to go through all of these. Step 1 was to clarify the problem, meaning contact your sponsor, which is your customer in this case, which could be your faculty mentor or company sponsor, and identify the problem and what they need. So the team, so these that I've listed here are the team assumptions that they needed to consider for their product, a handheld nailer, that it will use nail, it should be compatible with current nail magazines, should be able to nail into wood, and it should be handheld. So customer or the sponsor had some extra specifications and requirements for the project too, that it could be apply nail in a rapid succession, be light because it's a handheld, and it shouldn't be any delay when you trigger the tool. So in order to clarify the problem, okay, they use something, I don't know if you remember, but we call this a function diagram. So this is something absolutely you have to develop for your senior design. You need to have a function diagram of what you need to do. And what a function diagram is, you start with a box like this, which we call a black box. So handheld nailer, it needs some sort of energy input and output, it needs some sort of material, which is nail in this case, and it needs some sort of triggering the tool to be applied, and the nails to be applied to wood. You get this black box and you break down the problem into sub problems. Okay, so you have a big problem, which is your entire project, and you keep breaking it down into sub problems. You keep doing this until the problem is simple enough that you cannot break it down any further. Okay, again, I cannot emphasize this enough. This is the first step for your conceptual development, and you need to follow this step. The step 2 is to do an external search for your project. Some examples of external search, meaning you can interview lead users. In your case, it could be your sponsor. So you can consult the experts. Again, in this case, could be your faculty mentor. You need to do a literature search, patent search, and you need to do benchmarking of your product. So for example, that we are looking at, they interviewed some contractors from the show This Old House. They also consulted a rocket fuel specialist and an electric motor researcher. So at first look and at first glance, it might not be logical to interview a rocket fuel specialist for a handheld nailer. But if you look back at the function diagram, one of the sub problems they had was storing and releasing energy. So both of these fits into that sub problem. They also search literature, patents, stuff on that. And as I see, they look at energy storage such as flywheel or different battery technologies and stuff like that. The benchmarking, which is also part of the external search, is a study of existing products with functionality. So again, the emphasis here is on functionality, similar to that of the product that you are developing. And one of the websites that I provided you in ME361 was ThomasNet of the industry, that you can search any product and it tells you different kinds of it, different sellers, different manufacturers, and all of the information that you can search of. Again, I want you to remember it's the functionality. Okay. In the internal search of your step, this is where your team and the talent of the team comes into the play. Okay, so I have seen a lot of teams, first day of the project, they sit together and they say, let's brainstorm now. That is wrong. See that? That's a step 3. One of these bullet points is brainstorming. So these are, again, something that I've explained before. I briefly mentioned. You got to make analogies. What other devices do similar function and solve similar problems? Okay, think larger scales. Think larger, much larger. Think much smaller. Okay, you got to use wish and wonder. Remember, these are statements that starts with I wish we could, or I wonder what happens if. Okay, use related stimuli. So each of your team member generates an idea, or write it on a piece of paper, or puts it in an email, send it to the next person. The next person uses that idea, adds something to it, pass it around to the next person. And you do this and repeat this process until the idea keeps developing. Remember, the unrelated stimuli. The handheld nailer sent someone out with a digital camera. They said, pick random pictures of random stuff. A rock, a leaf, a cat, a book. Anything related or unrelated. And the team member brought the pictures back in, and they started discussing how a cat, for example, can be related to the project at hand. And these are just to stimulate your brain, okay? Stimulate your ideas. And some of them might not land you with a perfect idea, or some of them might lead to something. The other thing is set quantitative goals, which I usually ask my teams. Every member of the team has come up with 3 to 4 different concepts for their project. The other thing is the gallery method. Gallery method is when every person puts an idea on a piece of paper and you put everything on a whiteboard or on a cork board and you display it and you start discussing the idea. So for the team that we for the example that we have, a handheld nailer, so this is only for 2 sub-problems: storing energy, delivering energy to the nail. Okay, this is not for the entire product. Again, this is for those sub-problems. And here are examples that they came up with. And as you can look, they have explored everything in this stage. They have even considered geothermal, wind, steam, solar, cold fusion, nuclear reactions. You see, some of them you might laugh at this stage, but this is just looking at only one sub-problem. What are the ways that you can store energy? What are the ways that you can deliver that energy? Of course, some of them are not going to be practical for this project, but at this stage, everything is a fair game, and everything you can put it on paper as your idea or as solution to that sub-problem. So now you have these tens or hundreds of different little sub-problems. What are you going to do? So results of previous steps are hundreds of concepts and fragments solution to sub-problems, right? So you can explore systematically and organize and get rid of the bad ones, the ones that you were just laughing at in the previous slide. And we had 2 methods. One was classification tree, where you put your sub-problem here. This is your sub-problem 1. And you categorize the ideas that you came up with, or you did research, or anything that was in a step 2 and 3, external search and internal search. So the benefits of this, that you can see that some less promising branches. The other thing is you can expose some of the inappropriate ones. Like you can see, hey, nuclear, no, maybe not. That's not a good option for handheld nailer. But also you can get rid of the ones that you put too much maybe emphasize on and not looked at other options. So this kind of graphically shows where the emphasis is going. The other method that we talked about is the combination table. Again, these are for sub problems. So different ideas that you had for different sub problems, you can connect. So the table in 4 of these pictures are the same, only the line connecting them is different. So they combined solenoid to a spring to a multiple impacts, and they came up with one design like that. They did a rotary motion, spring, and a single impact. They had 3 ideas for that, and so on. So you can see by combining these, you can come up with so many different designs and ideas for those sub problems and moving on. Step 5 in all of these steps or this process is to reflect. And these are important. These are as important as previous steps because it gives you confidence that you have explored everything, and there's no other alternative function diagrams, and there's no other way to decompose the problem. Every external and internal, I should add, source been pursued and explored, and the most important one, the idea from everyone in the team has been accepted and heard and explored. So now you have these hundreds of thousands of little segments or concepts that you generated. So what do you do now? How do you select the best between them? So now we move on to the concept selection process. So this is a process of evaluating concepts with respect to customer needs that they needed, the sponsor needs, and other criteria that you can come up with. Compare the relative strength and weaknesses of the concepts and selecting one or more concepts for further investigation. The case study that we had in 361 was an insulin syringe, a reusable syringe, and the company who was the customer of this project, they needed some engineering specifications or customer needs. It was usually used for elderly people, so it needs to be easy to use, easy to handle. It needs to have a readable dose settings. It needs to be accurate. It's a medicine delivery. It needs to be durable. Also for the company purposes, it needed to be easy to manufacture, and of course it needs to be portable. So these are the questions that the team had. How can they choose the best concept? And again, remember, this is after concept generation. So they have generated a bunch of concepts that we're going to see. The question is, how can they select between them? So these are the best concepts that they had. And they are not identified by letters, A, B, C, D, G, F, and E. One important thing that you got to do before selecting your concept, every concept needs to be presented with the same amount of information. You cannot have a 3D rendering of one concept, a freehand sketch of the other one. If you have freehand sketches, when you want to evaluate and select between, they all need to be the same level of details, information, format, all of that. That's when you can make sure that this process is systematic and followed fairly and accurately. Okay. So, of course, there are different methods of selecting concepts. We talked about all of that, but we're not going to do that. In senior design, you are expected to do a decision matrix method. This is a structured method, and it helps to maintain objectivity throughout the concept phase of development process and guide the product development team through a critical, difficult, and complex process. So you generated a bunch of concepts. This is a conceptual design funnel. Now you are in this stage of concept selection. It's a two-step stage that we are going to talk about, and the outlet or result of it is going to be one final concept that you move on. The benefit of this method versus just sitting down and brainstorming and picking a concept is, if for any reason this concept doesn't work, you have a second best that you can go to. If for any reason that doesn't work, you have a third best that you can go to, and so on. So we're going to talk about screening and scoring. Screening and scoring, the difference between them, one was a quick approximate evaluation to just get rid of the bad ones. Select maybe the better ones and move on to the scoring, which is a more detailed and more careful analysis, and just pick one. So the difference is the first one might have 3, 4, 5, whatever number of concepts that you move on to. The result of this one is your best concept that you move on with. We had two tables, concept screening. The steps involved are the same. The difference in concept screening is you put all the concepts in a row, and you put your criteria. So this criteria comes from your sponsor based on their need, your mentor, faculty mentor, your team, stuff like that, what they need and what they need to see in their product. You just give pluses, minuses, and zeros. So remember, you need a reference at this stage. This could be from your benchmarking stage. This could be a similar function product. It could be any reference product that you compare everything to. And you only have pluses if it's just better than your reference, 0 if it's same as your reference, and you have minuses if it is worse than your reference. You tally them. You figure out, yes, this is a yes, absolutely no, nope, yes, hey, this one was not bad. If I revise maybe one category, I can do that, but I can also combine D and F together, make a new concept. Revise, combine, pick, then move on to concept scoring. So they combined D and F together, and the revised concept G, they added to the mix. They made another table. So now this time is concept scoring. This criteria needs to be a little bit more detailed than previous one. I know in my slides they're the same, but they need to be more details. If you have ease of handling, you need to break down into 3 little subcategories. Ease of use, 3 little subcategories, and so on. You dedicate a weight to each of them, and to see how important it is for the customer, for your sponsor to do that. This time, you give them between 0 to 5. So, not 0, 1 to 5. Let me find the equation for it. Okay, so it's much worse. It is worse. Same as, better than, and much better. So you get 5, 4, 3, 2, 1 scores this time. And I'm sure you can do the calculation, but it's going to be something like this. Okay, so this R, I, J, W, I. I goes from 1 to N. And so this is your total score. This is the row rating concept J for the ith criteria. Okay. And W is just the weight. Okay. So that's how the total scores are earned. You rank them. Again, remember, concept scoring, the result needs to be one concept to move on. If at this stage you do not get any definite answers, you need to go back or maybe revise some concepts and get back to this table. And here's a picture of the final product. And it turns out it was one of the combined concepts. So as you can see, none of the initial concepts was ideal for them. I've also included 2 examples that we had in 361. This is more to look at the criteria to get some idea, okay? Because so This was just a clip or a collar for barbell to hold the weights in. But you can see some of the criteria that they consider. Here is for a spill-proof beverage holder. And again, you can look at the criteria, what they consider. So these tables are just for you to kind of look at and get some ideas. Thank you.